Hey, how's it going, guys? So this morning I woke up and I went on Instagram and I saw this video.
You would not believe your eyes. You would not believe your eyes. You would not believe your eyes.
And I looked at it and I thought it was so funny. Like the dog was so cute with like goggles and stuff. But then I was watching it and I was like, that doesn't seem like there's enough balloons to lift up a dog that size. So then I was gonna hop out of bed and pop out my notebook and see how many balloons it would take to lift this dog of. It looks like it's about 10 pounds. But then I was like, why don't I just make a review out of it or a video out of it, and we'll use that video as MCAT review for Buoyant Forces. Now, this question is not a great MCAT review question, I must admit, because you have to use your calculator, but it does cover concepts about buoyant forces and Archimedes' principle, so it's still pretty useful in that regard. Anyways, let's get started. So I wrote this question myself. I pulled a lot of this stuff from the internet. Approximately how many helium balloons would it take to lift a small dog that is 10 pounds? I was just kind of estimating right there, and this translates to 0.454 kilograms from the ground. Assume the density of helium to be approximately 0.179 kilograms per meter cubed, and that of air to be 1.29 kilograms per meter cubed. Also, assume the mass of the balloon of the skins to be 10 grams each, and approximate the volume of each balloon to be spherical with diameter 0.3 meters. That's about 1 foot, so that's about how big the balloons were in the video. So let's just get started here. We want to first draw a free body diagram, right? So let's first draw a dog. Ooh, that's an... Ooh. So here's our dog standing on the ground, right? And it has a few balloons, right, attached to it. Let's see what colors. Right? And the question is, how many balloons, right? So from this, let's draw a little quick free body diagram. This is essential, right? So we have balloons pulling up on the dog. We're going to call that our F sub B for buoyant force. And then we have the weight of the dog going down. Whoa. Sorry, my computer is lagging. Weight of the dog. But then we also have the weight of the balloons, right? So weight balloons. So if you draw a net equation out here, let's say down is a positive direction. So we're going to have a positive weight of the dog, the positive weight from the balloon. Let's say balloons. And then the buoyant force is going up. So we'll define that as negative. Now in the video, you can see the owner pushed the dog, nudged it slightly, and then the dog went flying up. But before that, the dog was stationary. So we can assume the dog was at equilibrium. And so we'll say our net force was 0. All right? So the question is, how many balloons, right? So we're going to have to solve for the weight of the dog, the weight of the balloon, and then lastly, the buoyant force. So, yeah, let's get started. Let's first find the weight of the dog, right? So we were given that the dog had a mass of 0.454 kilograms, right? So the weight of the dog is going to equal to the mass of the dog times gravity, which is equal to 0.454 kilograms times acceleration due to gravity, 9.81 meters per second squared, and kilogram meters per second squared, that's going to be in Newton, right? And I did this calculation earlier. It should be, if you plug this in your calculator, you should get 4.454 newtons. All right? Okay, so what's next? The weight of the balloons. All right. This one's a little bit harder because we don't know what the weight of the balloons is yet, right? Because we don't know how many balloons we have. But we can find out what the weight of one balloon is. So the weight of one balloon is going to equal mass times gravity once again. But this mass has two parts this time, right? Because the total mass is going to be the mass of the skin of each balloon, which was given to be 10 grams, and I pulled that off of Google. So mass of the skin of the balloon, but you're also going to have some mass because you're filling the balloon with helium, and that helium actually has mass to it. And so we need to figure out the mass of helium multiplied by acceleration due to gravity. This is easy. It was 10 grams, right? So 10 divided by 1,000, we should get 0.01 kilograms, right? Now, mass of helium. How are we going to do that? We were given the density of helium, right? And so to find the mass of helium, we're going to have to find the volume of each balloon. And we were given that we needed to approximate the volume of each balloon to be spherical with a diameter of 0.3 meters. So if you remember, volume of a sphere, that's going to be, 4/3 pi r cubed, right? And we're given a diameter of 0.30 meters, which means a radius of 0.15 meters. All right? So we plug this in and we get 4/3 pi 0.15 meters cubed. And you plug this in your calculator and you're going to get, you should get 0.0141 meters cubed. All right, so now we can solve for the mass of helium. So the mass of helium is going to be the volume of your helium used, so 0.0141 meters cubed, and then the density of helium, which is 0.179, right? 0.179 kilograms, meter cubed. And you punch that in your calculator and you will get, let's see here, you should get 0.00252 kilograms. And so we're going to add the mass of our skin, right, 0.01 kilograms, and the mass of the helium that we use. And together that's going to equal 0.01252 kilograms, right? And so we get that the weight of our balloon, one balloon, right, that's going to equal 0.01252 kilograms, 252 kilograms, times acceleration due to gravity, right? Meters per second squared. And this turns out to be 0.123 newtons. All right? So what about the weight of all the balloons? All we're going to do is add a factor n, and n is going to be how many balloons we end up using. So we don't know what n is yet because we have to solve for that, right? All right, so then the last thing we need to find is the buoyant force, right? And so do you guys remember what the equation to buoyant force is? Because I don't. And actually, the way I remember it is by remembering Archimedes' principle, which basically states that your buoyant force is equal to the force of the weight that you have displaced. So the weight of the fluid that you've displaced, right? And so what does that mean? That just basically means For example, in water, if you displace 1 liter of water, the buoyant force that is going to exist is the same as the weight of 1 liter of water. And so when we write that out, it's going to be the density of our fluid that we've displaced times the volume of the fluid that we've displaced. And this right here is going to give us the mass that's displaced, right? And then we multiply by acceleration due to gravity, and that'll give us the weight that is displaced. In this specific scenario, the fluid is air, right? So we're displacing air, we're replacing it with helium, and that's what's giving us a buoyant force. And so we found volume earlier, right? The volume of the balloon is going to be the same volume to be 0.014 meters cubed. And then the density of our fluid, this is going to be the density of our air because that's what we're displacing, right? And that was given to be 1.29. Sorry, so laggy. 1.29, and this is kilograms per meter cubed, right? All right, and then acceleration due to gravity. So this is going to cancel out. We're going to get newtons once again, right? So the buoyant force, I should say one balloon, is going to be equal to 0.178 newtons, all right? So the buoyant force of all the balloons, right? So all, let's say all, it's going to be however many balloons we have, n times 1.78 newtons. So now we can plug all of these terms back into this equation, set it equal to 0, and then we're going to solve for n. So let's do that real quick. So the sum, my computer is so laggy right now. It's going to be equal to 0, which is going to be equal to, what was it, 454 newtons, right? Plus n times, was it 123 newtons, minus n times 0.178 newtons. And you're going to do some algebra, and you're going to rearrange and solve for n, and what you're going to get is n times 0.055 newtons is equal to 4.454 newtons. This is just after rearrangement. And so we get n equal to be 81 balloons. So 81 balloons, that's a lot of balloons, right? Like, I went back to that video and I paused it, and I counted like 25 balloons in the initial one. And if you remember the music that they played, Fireflies, it was a loop of, "You would not believe your eyes, you would not believe your eyes." And I think basically they were just telling us, don't believe your eyes, because I don't think there were enough balloons in that video initially. But it's not too far off, right? So 80 and 20, it's not crazy. It's not like this is 200 balloons or something. But I did do research, and I'll pop up the video right here. And there was someone that tried to do this, and they had to use 72 balloons, right? 72 balloons, and their dog was like 7 pounds. So our estimation right here isn't actually that bad. It's pretty close, actually, 80 for a 10-pound dog. But if you looked at that picture, there were a ton of balloons, and then if you go to the video, right, there weren't that many balloons at all. So I think maybe that's a cute dog, but I think it's lying to us.
You would not believe your eyes. You would not believe your eyes. You would not